Hi, in this video, I'm going to talk about Z-scores and how we calculate a Z-score. So what is a Z-score? A Z-score is basically just like a standard deviation. It is how far away you are from the mean. And also it tells you which direction you are. So you could either be right of the mean or left of the mean. So the first thing is a Z-score is always going to have a mean of 0 and the standard deviation is always 1. Now look at the normal model here. This normal model shows you, let me just show that. This normal model right here indicates that the mean is 0 and the standard deviation is 1. Now, negative z-scores are left of the mean. Positive z-scores are right of the mean. Now, a z-score has no units. So if I'm looking at a model and it represents, let's say, the weights of elephants, then if I calculate the z-score, that will have no units. It will not be kilograms or pounds or tons. It will just have no units. We have z-scores that vary usually anywhere from -3 to 3. Of course, they could go lower and higher than that, but anything that is 2 or beyond is considered unusual. But first, let's take a look at a z-score formula. It is actually a very simple formula. We have z is equal to x, which is basically your observation. So it's not necessarily a score. So it could be a weight, it could be a height. It all depends what your distribution represents. And then we have our mean right here, which is mu, our population mean, and our standard deviation. Now, I like to write the equation in words, and later on you will see why. All right, so here's a z-score formula, and we're going to look to see how we use it. Okay, if you look at your z-score, we have our normal model, we have our mean here, whatever it represents. We have 1 standard deviation, 2 standard deviation, 3 standard deviations, and our z-score correspond to whatever these numbers represent. So we would need to do an example for you to see what I mean. So let's take a look at an example. National results for the SAT test show that for college-bound seniors, the average combined SAT writing, math, and verbal score is 1,500, and the standard deviation is 250, and it is given by a normal model with the mean right here, 1,500, 250. It says, your SAT score is 1860. What was your z-score? All right, if we look at our normal model, I drew it already ahead of time to save us time. So the first thing we want to do is draw our curve. I'm going to have 1,500, this is our mean, and 250 is our standard deviation. So I'm going to count 250, that's 1 standard deviation to the right, another 250, that's 2 standard deviation, and 2250, 3 standard deviations. It's going to do the same thing going to the left. So that would give us 1250, 1,750. And keep in mind that 68% of our observations are 1 standard deviation right and left of the mean. We have 95% are 2 standard deviations of the mean, and 99.7% are 3 standard deviations of the mean. All right, but in this question, we want to know what would our z-score be if it was 1860? Well, where would 1860 fall on this graph? So we can clearly see that 1860 is somewhere between 1750 and 2000. So our score is somewhere, my score or your score, whatever you want to call it, is somewhere here. Okay, so this is the X we want. Now, keep in mind there are all these scores of individuals. So everywhere in this normal model is someone's score. And we have all these scores of the population. And where are you compared to everyone else, how they scored? So everyone's score is distributed around this model. 1500 is the mean, the standard deviation is 250, and you are right here. So we can ask this question in many ways. We can find out what percentile this is, but in this case, the question is asking what z-score, what is your z-score at 1860? Well, so we can easily use our formula, which is a very simple formula. So all I would need to do is say Z is equal, our score is 1860, so I would put in 1860. The mean is 1500, the standard deviation is 250, and then you would just simplify that and get your z-score. Now, I can already see that my z-score, based on what I have here, so here are z-scores that I have, and this never changes, by the way. The mean, if I wanted to standardize it, is always a z-score of 0. One standard deviation to the right, 1750 has a z-score of 1, and 2000 has a z-score of 2. 2250 has a z-score of 3. 1250 has a z-score of -1. 1000 has a z-score of -2. 750 has a z-score of -3. So if I actually entered any one of these values, I would get a whole number, and it would be one of these. But I can see that this z-score is somewhere between 1 and 2. And obviously it should be positive because I am right of the mean. So when we calculate this, I could enter it into a calculator and get the exact value. I'd do 1860 minus 1500, and that would give us 360. And 360 divided by 250 is what? So we can just enter 36 divided by 25. And so that gives us a z-score of about 1.44. So the z-score that corresponds to 1860, which is, by the way, right here, this is 1860, corresponds to a z-score of 1.44. So the z-score is 1.44, and that's pretty much it. Now, I can ask any type of question, or the question can be asked. You can be given a z-score, you can be given the mean and standard deviation, and you could be asked any one of these letters can be replaced. Remember, in any equation in algebra, if you only have one unknown and you know everything else, you can find that unknown. So for example, I can be given the z-score, the observation, and the standard deviation, and I could calculate the mean. Or I could be given the standard deviation, the mean, and the z-score, and I can calculate the observation. So the question can be asked in many ways using this formula. And that's basically how we calculate a z-score. Notice that I am 1.44 away from the mean. So the question can be asked, is my score unusual? In other words, does it stand out from the rest of the scores? So if you recall from the previous slides, I stated if you're more than 2 standard deviation from the mean, then your score would be considered unusual. But in this case, 1.44, even though it's much better than the average, is not an unusual z-score.